Alright friends, remember that in this lesson you're going to learn how to write equations for linear, geometric, or exponential functions. And we're going to call those explicit equations. We're just going to call them functions. And then we're going to learn how to evaluate for n, or the number of terms in the sequence. So let's look at this next problem here. We have a triangular numbers. There are numbers that arise from arranging dots into triangular figures as shown. And they basically, if you connect them, they look like a triangle, and that's why they're called triangular numbers. Question number 9 says, what is the 100th triangular number? And so in order to figure out what the 100th triangular number is, because they only give us 1, 2, 3, 4, 5 triangular numbers here, we have to come up with an explicit formula for this. So what I like to do whenever I have to come up with a formula is I like to see my numbers in a table. So what is the 100th regular number? Well, for that I need to figure out a rule. Now let me show you a little hint, because the first formula that we had to figure out, we had to come up with a rule. And so when I try to come up with a rule, of course the first thing that I do is I try to figure out, first I try to see a pattern. I try to find the difference between the first term and the term after that, sort of like a recursive way. Recursive, of course, meaning that whatever your next term is, you have to look at the term right before it. So in here we added 2, we added 3, we added 4, we added 5, and so we sort of see this pattern that whatever your term was before, you're gonna add 1 more. And so that is exactly the constant here that you see. So a couple of things. Usually when you have 2 levels of change, this is level 1, level 2, that ends in a constant. When you have 2 levels of change, that means you're either dealing with a geometric or an exponential function. Geometric, of course, is when you're going to have either n times n. And exponential, of course, you're going to have n to the power of 2, or to some exponent. It could be power 3, it could be 4th, whatever. So it's not going to be a linear equation, is what I'm trying to say. So it's not going to follow the y equals mx plus b form. It's going to either multiply by itself or to an exponent. That's what having 2 levels of differences tell me. So that's just a little tip there that was not part of this lesson for you. Now, once I know that I'm dealing with some sort of geometric, because this is triangular figures, I know this is some sort of geometric shape, right? And so let me see what I can do here. I know that if I add, I know there's going to be a plus 1 here somewhere, right? I have to add 1 at some point. If I, what would be equal? If I add 2 plus 1, okay, but if I pick this second set, 3 plus 1, that's not going to give me, that's going to give me 4. So this is kind of like just a trial and error thing. If I use this and multiply n times n, would that work? So 2 plus 1 is 3 times 2. No, that's not going to work because it gives me 6. But if I divide it by 2, it's going to work because it gives me 3. Let's see if that works. That might work here. Let me pick a different set of numbers and see if that would work, okay? So if I have n, that's 3. And if I have n times n plus 1, that's going to be 3 times 3 plus 1. That's going to be 3 times 4. That's going to give me 12. If I divide it by 2, it's going to give me 6. And this is going to be 3. Okay, so we got ourselves a formula. We have t of n is going to be equal to n times n plus 1 divided by 2. Again, we got the plus 1 here. We knew at some point we needed to add the plus 1. We knew that it was also a geometric shape, and that's when we're looking at it multiplying by itself at some point. And then just by trial and error, we figure out that if we just divide it by 2, it's going to give us exactly what we want. So that's kind of like a long way to get a formula, but it's real, right? The struggle is real. So let's look at number 10 that we actually answered our problem, and we didn't actually answer number 9, which was the 100th triangular number. So if n equals 100, we just plug it in. It would be t of 100. So it's 100 times 100 plus 1 divided by 2. 100 plus 1 is going to be 101. So 100 times 101, it's going to be 2. Divide 100 by 2 and just multiply 50 times 101, right? And so we know that 50 times 100, 50 times 100 is going to be 5,000. And we know that 5,000 plus 50 is going to be 5,050. T of 100 is going to be 5,050. Ta-da! How can you be sure that your formula works? I know that I kind of took you the long way around to finding this particular formula, but some of you may have been thinking as I was doing this, there's an easier pattern. And that's right, there is. Because if you notice, if we just complete the square, as I like to call here, in this shape and just fill it in, you will notice that this becomes a square. 4, 4, 4, 4, right? 3, 3, 3. And so this is basically 3 times 3, if I'm picking this, divided by 2. So this is basically a square cut in half, and that's where divided by 2 came from. So that's another way that we can make sure that this formula works. Okay, so in this lesson, we learned how to write an equation for a function, and this function can be geometric or exponential or even linear. We spent a lot of time with a geometric function, and for the problem set tomorrow, that is exactly how your problems are going to go. You're going to have to come up with a rule, or in this case, a explicit formula for situations where you have a graph and a table. And they will ask you also how to evaluate for a variable, in this case n. But that's the other skill that we learned to do today. So make sure that you know how to do both these things for your problem set tomorrow.